we're going to be talking about central tendency, mean, median, and mode. Now, mean, median, and mode are what most people think about when they think about statistics, especially descriptive statistics. When I ask my students, what's descriptive statistics about, they'll be like, mean, median, and mode. And sometimes they'll also say standard deviation, right? So I know that this is largely what sticks in people's minds. All right, so we're going to be talking about these three measures of central tendency. Then we're going to spend a little bit more time on mean. We're going to review the summation symbol, sigma, uppercase sigma, rather. And then we're also going to talk about the different formulas for population mean versus sample mean. Then we're going to talk about some Excel examples. And finally, we're going to compare these measures of central tendency. All right, so central tendency. Basically, the idea is we want to be able to summarize a distribution, right? And we've learned about some different ways you could summarize it, like the shape, for example. You could say, oh, it's a uniform shape. It's a nice way to summarize a distribution. So, but shape is just one dimension that you could summarize a distribution on, a way that you could describe it on. Central tendency is another dimension that you could describe it on. So central tendency you could think of as the middleness, right? How do you say what's the middle of a distribution? Well, there's a couple of ways. So when we talk about mode, we're going to be talking about most frequent value as sort of the center member, right? So in this case, with 1, 2, 2, 3, 4, 5, 7, 2 is the most frequent value, right? And so because of that, we're going to say, okay, that's one way we could describe the center. The median is literally the middle value. In order to find the median, it often helps to line up your distribution in order, right? So here we have the least on this side and the greatest on this side. So here we would just count to the center. So since there's 1, 2, 3, 4, 7 numbers here, we know that's an odd number. So here we just pick the middle value, and that's the median. Now let's talk about mean. Mean is what people often call the average member, the average value. And with mean, we actually care what each value means, what each value sort of, the extent of each value. And so because of that, what we're going to do is add up, sum up all the values in our distribution, in our sample, and divide by n, right? Divide by the number of values you have in your sample, right? So here we're just going to add all these up. So here's 5 and 10 and another 10, 20, 24, right? So 24 divided by 7. And that will give you the mean. So this is probably something like 3 and 3/7, right? So that's our mean. All right. So now I've changed that same distribution just slightly. All I've done is I've added an extra number. And let's see what changes, right? Does the way we describe the central tendency of our distribution change? Well, let's see. So remember, mode, I think I used red before, is most frequent, right? Does our most frequent value change? In this case, no. 2 is still our most frequent value. Well, what about the median, the middle value? Has that changed? Well, here we have 8 numbers in our distribution, right? And because of that, there's no exact middle point, right? The middle is in between 2 numbers. In that case, what you do is you take those 2 numbers in the middle and you divide by 2. You add them up and you divide by 2. Basically, you find the average of the 2 middle values, or average of 2 middle values. right? So in this case, it would be 2 plus 3 divided by 2. So something like 2 and 1/2, or 2.5, right? So that would be our median. Notice that our median has changed a little bit. Because we added something over on the smaller side of our distribution, our median has slightly shifted over. Now let's think about the mean, or the average. Well, let's add them up and see. So 0, actually, because I added a 0, the actual value of the sum doesn't change, so that's 24. And now we're just dividing by 8. And so our mean is now just 3 instead of 3 and 3/7. And so because of that, once again, because we added a number that is small in our distribution, our mean has shifted over a little bit towards the smaller side. All right, so that's basically the ideas of central tendency. Now before we go on to talk about the actual formula, the formal algebraic notation for mean, I want to talk a little bit about the summation symbol. So what we want is some kind of symbol that will tell us, add up all the numbers. I don't care how many numbers you have, add them all up, right? So it would be nice if we had a symbol that could do that, right? So here's the summation symbol. It looks like that. Sigma, uppercase sigma. We're going to be using lowercase sigma for something else. So uppercase sigma, and usually people will write some sort of variable here to represent, okay, which variable set you want to take from, right? So add up all of age, right? So if it's age, and I represent that with the letter A, so if, let's say, A equals age, right? And I want to get the average age, right? Then maybe I'll put A here, right? So sum up all of A, right? Sometimes the summation symbol is written like this. Implicitly, there's always a little more detail that sometimes they don't show you or you can't see, right? So here's often what's hidden underlying this. Usually, this is saying, add up everybody in your set A. Take them all the way from I, the index, from the first one, right, I equals 1, all the way to the last one in your set. And remember, how many are in our set is usually represented by n, right? So from 1 all the way to n, so 1, 2, 3, 4, 5, 6, 7, all the way to n, whatever n is, add up A, right? And so here we're going to put a little A sub I. This means this. Okay, so here A is age. And let's say A is actually the set, 5, 10, and 15, right? Here's the corresponding I, 1, 2, and 3, right? So what the summation symbol is telling us is for I equals 1, for this one that this index points to, add up A sub I, right? A sub I, the first A. Then add to it A sub 2, which is 10. Then add to it A sub 3, which is 15, right? And so that's how the summation symbol works, all the way up to n. N in this case is 3 because there's 3 numbers in our set, right? Let's do one more example. So here's my summation symbol. And now I'm going to say add up x, right? And let's say x is number of books read this summer, right? Whatever, right? And x is going to be 2, 4, 6, 8, 10, right? Well, we know that implicitly it's saying go from I sub 1 all the way to n, n in this case is 5, right? That's 5. And I'll write the I here. So this is I sub 1, I sub 2, I sub 3, 4, not I sub, x sub 1, x sub 2, x sub 3, x sub 4, x sub 5, right? So here, this is telling us, go all the way from x sub 1 to x sub 5 and add them all up, right? So this is just a formal way to tell, a formal algebraic notation to say, add up all the numbers in your set, no matter how big or small your set is, all right? All right, now that you know the summation symbol, now we can start creating the formula for mean for samples and for populations. All right, so now let's think about the mean for the sample. The mean of the sample is always represented by the number x, by the symbol x bar. Now, how do we calculate x bar? Well, we have to add up all the numbers in our set and divide by the number of items in our set, right? We know that that number of items is n, right? And we could use our summation symbol, right? Doesn't have to have these little feet, but you can. We know that it's the summation symbol for all of x, right? So this is one way that you could write it, and that's a very simple way. And it's implicit that it's telling you go from I equals 1 all the way to n. But just for our purposes, I'm just going to put in the hidden stuff just to show you as well. So it's really implicitly saying go from I equals 1 all the way up to n, however many n is. And because of that, add up each x sub I. X sub 1, x sub 2, x sub 3, all the way to n, right? So that's one way that you could see it. But you don't need all this complicated stuff. That's sort of optional. All right. Now, if you had the population of the world, like, so if you had the distribution of the actual population, which is almost impossible to get, but let's say for some reason you wanted to write a formula for it, and actually you do want to write a formula for it because it's going to be handy later on. How would we write the formula for that? Well, for population, we don't call the population mean x bar. Instead, we call it mu. Right? So our population mean is called mu. And here, we want to add up all of the x's, but here we use an uppercase X because we're saying draw now from the population distribution. And instead of a lowercase n, we're going to write uppercase n because uppercase n means all of the, how many values you have in your population, not just your sample, lowercase n. And I'm going to put in the invisible stuff, go from uppercase x sub 1 all the way up to big N, right? And here I'm going to put that index, right? So there you have it. This is the population formula, and this is the sample formula. And although there's some slight differences in notation, for instance, here we use the Greek letter, here we use the Roman letter, here we use uppercase, here we use lowercase, right? Except for I. I just means index. It just means like a little counter or pointer to each thing in the set at a time. So I is like, you could use J or whatever you want, but we usually I for index. So other than those little characteristics, the meaning is the same. It just means add up all of the values in your set and divide by however many you have in your set. All right. I want to point out one other thing here. So here, one thing you could see is that if you happen to have the mean of your sample, so if you happen to have x bar, and you multiply n to each side, I'm going to multiply n to each side invisibly here, right? So I'm going to multiply n, right? Then you get the sum of all your x's, right? So that's just algebraic transformation, right? I haven't done anything to change the formula. The formula stays the same. But this little trick is going to come in handy later on. So just keep that in mind in the back of your head.